Hey, so today what I want to do is talk to you a little bit about recursion. I'm not necessarily going to do a grand overview or anything like that, but I think there's a couple of points that I think are sometimes really misunderstood about recursion, and so I want to kind of cover it in a mishmash of sort to give you some ideas as to how to be able to improve what Zybooks is already teaching you. So let's go ahead and get started. So the first thing that I wanted to show you was just recursion. What's kind of nice about recursion is that it shows up in lots of different and really cool ways. And so, for example, this is actually a picture of a Romanesque broccoli. And the reason that I wanted to show this is because it actually shows, or is in a way a natural fractal, which is just a tinier copy of itself. And that's really the basis for recursion. I wanted to give you just one more slide to be able to show you this stuff, right? Where what you're seeing with recursion is that recursion is just a smaller copy of itself. Now, in this situation here, we're kind of, doing this forever, but you could see that really what's happening is that recursion is just a smaller copy of itself that's happening. And so really once you kind of get that idea of that happening, I think it makes things a little bit smoother. Now, how does this apply to programming? For programming, what we're going to be doing is that we're going to be having a function call itself, right? And so trying to understand how that ends up working is important. So let's go ahead and do that. All right, so let's go ahead and assume that we actually have a countdown, which I'm going to end up writing down here. We're going to have a countdown function, and the countdown is going to have a count of 3. Okay? So let's say that we have that function down here. And so what we do is, if this was what was called, right, we'd have count int be 3, and then we would end up saying is 3 equal to 0. Well, 3 is not equal to 0, so we're going to kind of skip down to printing out a count variable. And so I'm going to end up making an output kind of over here. I'll just say it's output or something like that, so that way you could see. And then for here, what we would end up doing is we would end up printing out the value 3. Right? Now that we've gotten down to this line here, we now have this value where we say, okay, now count is 3, right? And so now what we're going to do is we're going to count 3 minus 1, which ends up being 2. And I'll say, okay, so now what we're doing is we're going to end up calling count with 2. So I'm going to make a new kind of window here. I will also call it countdown. Right, and then where we have a count variable, that is now going to be 2. Okay, so now we have something that's 2 up here, and now what we're doing is we're saying is 2 equal to 0. Well, 2 is not equal to 0, so we end up jumping down here to false, right? And we're going to end up printing out a 2 into our output. So let me bring it to here. And at this point now that we've finished printing that out, we go ahead and get down to this function call here, where we have count int is 2 minus 1, right? And so what that's going to do is that's going to get us to a count int of 1. And now we will have another countdown, and where I'm going to say count is 1. Okay, and count is going to be 1 here, right? So 1 is not equal to 0. We're going to go ahead and print out 1 again here. And then we're going to come down here. And so countdown of 1 minus 1 ends up being countdown of 0. And what we'll do is we'll have another countdown function, right? And just the other thing that you want to make sure that you guys realize is because we have all of these functions where we're going to have this value of 0, right? Every time that we make one of these new functions, these other ones are kind of hiding, right? So we can't necessarily, we're not really supposed to be seeing them. So anytime that we're referring to count, to count in, we're referring to the one that we're currently in, right? So here count in is 0, and we say if count is equal to 0. Finally, we get to is 0 equal to 0. So we're going to go ahead and say go. Okay? At that point, right, we ended up doing that here, right? Once we reach this, we kind of reach the end of this function, and then because that function is done, we now go away, right? So that means that this entire count is going out, right? And then now we're back to what was previously there, which is the 1. So now that 1 is
done, and we kind of move to the next line. The next line is done, so we go ahead and take that off, and so now we have countdown of 2. Well, countdown 2 is also done, so we're going to go ahead and take that off, right? And then countdown of 3, that leaves us with countdown of 3, which we also are going to end up taking off, and then that ends up being our entire program, right? And so here you ended up seeing that the output was 3, 2, 1, go. What would end up happening if we actually flip them like that? And so let's go ahead and take a look at that. So let's go ahead and do countdown, right? And we have this value of 3 for count, right? And then we go ahead and say if count equals 3, that's false. So now what ends up happening, right, is that we get down to this countdown, which means that we immediately kind of move to the next phase, right? So now we come down here, right? And with 3 minus 2, that's going to mean that our count is now 2, right? So that means we kind of come up here, and 2 equals 0, that's not the case. So now we move down again here to count down, right? And count down now becomes 1. So now we have to kind of move over and create a new countdown function where count is 1, right? And so we kind of get to this line here. If 1 is equal to 0, it is not, so we're going to jump over here again, right? And we now get to countdown 0, and so we're going to have that function over here where count is 0, okay? And now I'm going to go ahead and make my output over here on this side. And the reason that I'm doing that is because once we get up here and this is 0, we finally get to this stage where is 0 equal to 0? Yes, it is, right? So this is where we finally say down here, go, right? And then once we kind of reached go, we jump all the way down to the end. That means that we finished the function. So that means that our function can now return, which means that this ends up going away. And so now we're back to green, okay? And so because green, we have to think about, well, where is green currently? Green currently is at countdown, right? Countdown of 1 is currently right here. And so now we're going to end up moving to this line, which means that we are now going to print out we're going to look and we're going to say, okay, let's go ahead and see out what count is. Well, what is count in this situation? Count is 1. So we are going to go ahead and print out a 1 right here. Okay, and then once that is done, now that we've gotten here, we get down here, we're now at the end of the function. So that means now this count of 1 goes away, right? And we now come back to count of 2. And so when we look at count of 2, we now end up saying, okay, we're done with that one. Let me go ahead and move to this next line, right? So now we end up printing out the 2, right? And we reach the end of the line there. So that means that now count is also going to go away. And we are back to, this count is, like I said, is also going to go away here. And now we're back to the blue line over here where we just have regular count. And so with regular count, we're going to move that down here, right? And then we end up printing out 3, okay? And then we kind of get there, and then finally countdown is done. So notice how in both situations there's a slight difference, based off of the ordering in how we do these two functions, right? When we end up moving it in one, it has a different effect than when we have it after the recursive call, right? If we make something before the recursive call, like we have here, right, that ends up happening first. If we end up doing it after the recursive call, it ends up happening later and has a slightly different feel to it. And so I just want you to be aware of what ends up happening in those situations when you end up making an action after a recursive call or making an action before the recursive call. All right, so the next thing that I wanted to talk to you about is just when you are thinking about debugging,
there's something that you would end up being able to do. Most of you are familiar with writing cout statements. I would definitely encourage you to write cout statements in your code. The one thing that I'm going to add is that if you are still kind of feeling a little wheezy about recursion and how that works, I would definitely encourage you to use to make a variable called indents that is of type string. Okay. And what you would end up doing is you can end up initializing it to be an empty string initially, right? But then when you have it, you're going to end up having it as an argument, and you're going to have your normal variables in your function, but then at the end you're going to introduce an indents plus, and then you're going to end up putting a couple of spaces in there, right? And so this is going to allow you to see sort of when you're making recursive calls, how that output actually ends up affecting it, right? And so if we end up kind of coming back to the other function that we just did, this count down, really what I'm advising you to do is to try and make a string over here, right? Call it indents, and then inside of this cout right here, you would end up having just an indents. You would just say indents here, right? You know, and then yeah, you would just do the indents, right? You'd put all of this information kind of right here, okay? And then what you would do over here is that you'd put a comma. You'd say indents plus, and then you do the empty string like we had over there, and then also to add string indents here, okay? And so you would end up adding the argument right here. And the reason that that would be nice is that would allow us to, in these types of situations over here, be able to see how the recursive calls are happening, or how many calls we're into a certain thing. So rather than kind of saying 1, 2, 3 like this, you would probably see it as 1, 2, 3. Right? So that you would end up being able to say, okay, because it's being indented much more, that means that we're kind of have more recursive calls. And similarly, if we were to have the indents in this other function over here, you would actually see it as 3, 2, 1. And so what I want to do, the last thing that I want to do is talk to you about writing recursion. And so writing recursion can be broken down into two different sort of phases, or can be broken down into two subproblems. The first thing that you might be thinking is, if I'm trying to write something recursively, what is the simplest solution that I could potentially return? And so we tend to call that the base case, right? That is, you know, in a scenario where you're thinking about the simplest or the easiest answer that you could come up with, something where if you think that something is really hard, what's like the easiest version of that recursion that you would be able to solve, right? And so that would be, you know, think most of the time if you're thinking about numbers, that's usually something that revolves around, like, you know, reaching 0, or, you know, reaching something that's empty. You know, that tends to be kind of the easiest potential answer that we would give, right, in some of these problems. And so we end up writing that as being the base case. And then the second part is writing what we end up calling to be the recursive step. And the recursive step I want you to think about as just, if I have a particular problem, right? If I have a particular problem, how do I break it down into that same problem that I'm currently thinking about, just having it be just a little bit smaller, right? So if you have something that is, you know, very hard, how do we make it to be the same problem but just slightly less hard, right? And so kind of going back to the countdown example, I understand that it's trivial, but it's kind of like, if I have to be tasked with counting down from 3, well, let's assume that counting down to 2 worked. If that was the case, how could I then just leverage that and add 3 to it so that I can say, yes, I've successfully counted down from 3? And that's pretty much the entire thing for what I want to talk to you about with recursion. I know that recursion is something that's scary, especially if it's something that you haven't done a lot of. And so one thing that I would encourage you to do is to just to make sure that you are using the debugger, right? So make sure that you leverage that to put a breakpoint in one of these recursive calls so that you can see the call stack and the variables as they're going through. And if you need any help with that, make sure to send me messages on Slack so that we can set up a Zoom meeting, and I'm happy to try and go through any of that with you guys. All right, hope you have a good one. Good luck.